All right. Today's date is 2/27. Let's get our marker going. 2/27. I again am up at the Mimeo board, so that's why my handwriting is a little bit off if you're watching the video. All right, 7-4, arithmetic series. Again, it's arithmetic if it's just one word. If it's an adjective, it's arithmetic. So let's do some review. This is a review of 7-1, sequence. What is a sequence? And Rochelle remembers this from yesterday. Daisy, if you watch the video, you'll remember this from yesterday. A sequence.
Isn't it like a list?
It's a list, exactly. So just a bunch of commas.
But you said no. No, you didn't say a list. You said I watched the video.
So give me an arithmetic list. That means you're adding something every single time.
So like 100, 101, 102, 103.
100. Oh, I still don't have the undo button set up. I have an idea for how it's going to work, but I still haven't implemented it. 101, 102, etc. All right, so that's an arithmetic sequence. How do I turn that into an arithmetic series again? Series?
Oh, it's 100 plus 101 plus 102.
Oh, so you just
Plus, yeah, 101 plus 102, etc. So dot, 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 dot. An ellipsis. By the way, it's not called dot, dot, dot. It's called ellipsis. We know it's called an ellipsis. So how is a geometric sequence different than an arithmetic sequence? Geometric means you're not adding or subtracting, you're multiplying. So give me an example of a geometric sequence.
Oh, me?
Anyone?
Like 100, 1,000.
That works. I mean, can we do something smaller so I have room to write it? Otherwise, I'm going to run out of room after two numbers.
So,
Start with a small number, like 1 to 10 or something.
2,
2.
4, 6.
Oh, not 2, 4, 6. 2, 4, 8. And then 16. And then Daisy, how would you turn that into a geometric series?
You would do 2 times.
2.
Right?
That's a good idea. So instead of having commas, change it to a multiply because geometric means multiply. Unfortunately, no, because series always just means add. So even though arithmetic, the pattern for arithmetic is add and the pattern for geometric is multiply, series always means just add the list. So 2 plus 4 plus 8 plus 16. All right, good. All right, it's that time. We're talking about our second favorite mathematician in here. First favorite is Euler, Leonhard Euler. Second favorite is Carl Friedrich Gauss. He is up there on the wall. He's number 3 up there. Who wants to read? Who is it going to be? I'll get nice and close so it can pick up the microphone. Go for it, Rochelle.
Carl Friedrich Gauss
Yep.
is one of the greatest mathematicians of all time. When he was only in primary school, his teacher told the class to add all the numbers from 1 to 100. 4 plus 2 plus 3 plus 98 plus 99. Gauss shocked his teacher by finding the answer in only a few seconds by doing the math in his head. What trick did he use?
Yeah. I mean, we could try this out, and I could be like, okay, you have 2 minutes to solve this. Go, 1 plus 2 plus 3. I'll even give you a calculator, and you still won't be able to get it in time. So he used some trick. He like multiplication pretty well in primary school, but he basically just used multiplication to solve this. How are we going to do that? By the way, I didn't say this explicitly, but we are dealing with this category right here, arithmetic series. So this box is what we're dealing with today because obviously the pattern is add 1, add 1, add 1. So it's arithmetic, and then for adding, it's called a series. So how the heck are we going to be able to add these up really fast? By the way, our homework tonight, we're going to be adding up from like 1 to 1,000 like that. We have to find some tricky way of doing it. You guys want to see how he did it? All right, let's move this up to the top of the board so I have some room. So what Gauss did is he saw rainbows or smiley faces. He saw pairs. So 3 and 98 is a pair. If I add 3 and 98, what do I get? 3 plus 98 is 101. Another rainbow, 2 and 99 adds up to, whoa, 1 plus 101 is, whoa. That's what he saw. He saw if I take the very first element and the very last element and then add them, It's the same thing as the second element and the second to last element. Add them and keep taking pairs and adding them together. They'll always add up to the first element to the last element. Look at the first, look at the last. 101. They said, okay, how many of those are there? There's one pair there, one here, one here, one here. How many pairs were there in total? Can you figure that out? There were 100 numbers, and then how many pairs were there? 50 pairs. 50 pairs of 101. So in his head, he did 101, and then we are going to multiply that by 50. This 50, and we're going to write in our notes, this 50 is the number of pairs. This is the number of pairs. 101, the way that we found 101, that was the first plus the last. So what is 50 times 101? And he did that in his head. It's 5,050. The answer here that he found in only a few minutes is 5,050. And if you have a calculator, I'll open up my Spotlight search. So 101 times 50, just to make sure, 5,050. All right. So now that we understand the process, or at least vaguely understand the process, let's try to come up with our own general formula. We have basically the key elements right here. So let's say I give you three things. If I give you how many numbers there are in the list, how many entries there are, I tell you what the first number is, and I tell you what the last number is. With those three pieces of information, you should be able to tell me what they all add up to. Let's make the formula together. How are we going to do it? What did we really do? You can use, you don't have to do specific formula things. You don't have to say A sub n. You can just be like first, last, number of terms. So number of pairs is tricky, right? Because you can say number of pairs, and you'll have to remember what that means. But if I told you that there are 100 numbers in this list, that's just the numbers of the list, right? So let's make it a little bit more general. And instead of saying number of pairs, we're going to say the number of numbers, right? So total number. So what's the best way of saying that? The total elements of the list. Do you like elements? Do you like that word? Or do you like number of numbers? What makes the most sense for us in our formula? It's for you. Number of lists, entries, number of entries. What do we want to say here? Number of numbers. All right, we'll say that it's the number of numbers. And in order to turn that into pairs, what do we do with that? We had 100, and then what do we do to get to 50? Yep. So it's the number of numbers divided by 2, and then we multiply that by, we're going to multiply this by there it is. In parentheses, first plus last. End parentheses. There's our formula. This is our key formula that we're going to be using for the rest of the day. Let's try it. Let's try out our new machine here. We'll leave it up there at the top.
So this one will be 2,500 times by 5,000.
How'd you get to 2,500?
Because 5,000 divided by 2 equals 2,500.
5,000 would, are there actually 5,000 numbers here? Does it go 1, 2, 3, 4, 5, all the way to 5,000?
No. So it's 495. No, 4,995.
So remember that's counting by fives.
Oh.
So there aren't 5,000 elements. If I were to divide each of these by 5, what would I get? And so if I divide 5 by 5, I get 1. If I divide 10 by 5, I get blah, blah, blah. If I divide 5,000 by 5, I get 1,000. This is very similar to what we just did for our previous case, where we add up 1 plus 2 plus 3 plus 4 all the way to 1,000. it tells us how many elements of the list there are, how many number of numbers we have. How many numbers do we have? We have 1,000. So using our formula up here at the star, we have 1,000. We're going to be dividing that by 2. Multiplying by what, Daisy?
Oh, 5 plus 5,000?
Close.
Or 1
Close.
1,000, right?
So it's going to be first plus last. First, last.
Didn't I just say it?
You said 5,000,
Oh, 5 plus 5,000?
which is 5,005.
Wait, I thought I said that.
Did you?
I
No,
don't.
wait. I
Okay.
did? I don't know.
I apologize then.
Wait, how come you have to put a 5,005 for that one, but not for the 1,000?
Because this was just counting how many numbers there were. So because I'm counting by 5s, you really have to, I guess the hard part about this is how many numbers are there? And there needs to be a way to do this for harder problems. Because what if I did 6 plus 11 plus 16 plus 4,996 plus 5,001? How would you tell how many numbers there are on that list? And here's the answer to that. So by the way, let's solve this problem, then we'll come back here and ask the question, how many numbers? So we'll come back to this question in a sec, but let's calculate this. 1,000 divided by 2 is, and 500 times 5,005, we'll use our calculator. 500 times 5,005. 2,502,500. All right, 2,502,500. I'll put commas so that it's easier to read. There's our answer. Does that answer make sense? Can you get 2 million just by adding 5 plus 10 plus 15? The reason is because you're adding multiple thousands over and over again. 4,000, 5,000, adding 3,000. Once you add up so many thousands, you do eventually count up to 2 million. Past 2 million, actually. Okay, so the really hard part about this question is, how do you figure out the number of numbers in this list? The number of entries in that list? And I'll give you a formula that'll help out. So you're going to do last minus first, all of that divided by however much, you can call it the pattern, the rule, or most people call it the common difference, how much you're counting up each time. So in this case, I was counting up by 5, right? So what would you like to put here? Should I put common difference and be formal? Yeah, common difference. I'll say common difference. I'll just abbreviate and say diff. Okay, well, what was last minus first? 5, oh. We're going to have to modify this formula in a sec because I just realized the problem with it. But last minus first, 5,000 minus 5 is?
4,995.
And then we have to divide that by
5.
5. And then you'll get 999. So just showing you how the calculator work. 5,000 minus 5, we did indeed get 4,995. I'm going to put that in the parentheses now. I'm going to divide that by 5. And we get 999. So this formula is really, really close, but it's off by.
By 5.
494.
So remember that our answer, there were this many numbers.
Oh.
So we're off by 1. So on our formula, we just add 1. Plus 1. There's our formula. This formula, we should also star in our notes. To find the number of numbers, do last minus first, divide by common difference, then add 1. Always add 1.
I suck at doing stars.
We just talked about it.
All right. So we are now on the back page. We are on example 2. So we're still going to be using the same formula. This formula is really nice because it actually tells us the number of numbers. What am I going to do? I still am using the same formula, so I'm going to be doing what? Formula says to do something. Waiting on you two.
So it's 5 times by 1 minus 8.
All the way to 600.
So say again, 5 times 1?
Right, because you're starting
with one.
from.
You're starting with one.
Right?
That's the index that it starts at 1.
Yeah.
Oh, wait.
So 1 being plugged in,
Oh.
5.
5 minus 8 equals -3.
So the first number here, if I actually look at what this sum is, it goes -3, then 2, then 7, ... Well, actually, it's a series, so I should be adding those. So this is where I need an undo button, undo on the computer. So it should be -3 plus 2 plus 7 plus ... And it ends where? What's the last value that you plug in?
600.
You plug in 600 into k, right?
So that would be 3,000.
3,000?
3,000 minus 8, that would be 2,992.
There it is. Now we have the first entry and we have the last entry. Do we have the total number of numbers?
No. I mean, we do.
We do.
Okay, we start at 1.
We start at 1 and then we go to,
600.
how many numbers are there between 1 and 600, including 1 and 600?
600.
Is it 600 or 601?
You're not even finished.
Is it?
601.
It's not 601.
What?
Nope. The way that you,
599.
No, including them.
including 1 and including 600, there are 600. Should I show you the formula for this one?
You would know.
It's going to be this number, so it's going to be top minus bottom plus 1. You always plus 1. You always plus 1. So top minus bottom. 600 minus 1 plus 1. So you get 600. All right, so now that we have the total number of numbers, which is 600, we have the first number, we have the last number, plug them into our formula, and we get what? I'm ready to write. Use our formula that we had from
Wait, how did you get +2 and 7?
Oh, because
the pattern.
plug in 2 for k, it'd be 10 minus
Oh,
8.
right. Okay, I'm sorry. I did not see that. Okay.
No, you're good. Yeah, that was a good question.
I got it.
All right, so what am I going to do with my formula to actually add all these together now, using Gauss's rainbow idea, his pairing idea?
Number of number over 2 plus divided by first plus last.
Perfect. So fill that in for me.
Okay, hold on. So it'd be 600
600
divided by 2
divided by 2
times it by
times it by
600. No, 2,990. 90. No, 80.
What am I doing?
80. 2,980. Not 9. 2,981. And then it's 2,000.
Wait, -3.
89. Yeah, because the first plus
Oh.
last. And because.
Yep, so I'm adding my first entry, my -3 right here. I'm adding my last. So I'm really doing a pair like that. I'm pairing those up. And how many pairs do I have? 600 divided by 2 pairs. So now we do this on our calculator and figure out what our answer is. So it's going to be 2,992 minus 3, which is 2,989. That's going to be multiplied by, I believe you, times 300. And our answer is 896,700. 96700. Cannot write 896,700. Yeah, so 896,700. Ta-da! Ready for the next one? Our third and final possibility, example 3. We have an arithmetic sequence. Sequence means a list with commas. And that list is defined by, what does this mean? A sub 1 is equal to -3. What is that saying?
That's the first.
That's the first value. So if I'm actually listing my sequence, it looks like this. -3. What's the next number? What's the rule?
Plus 4.
So Daisy, what's the next value going to be?
Plus
1, then 5, and blah, 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 blah. And eventually, I'll get the last value. How do I find the last value?
So what are you trying to find?
The last value. I want to find the last value of the list.
Oh, we're trying to find what, like, you know how there's like the X and Y tables thing? And you're trying to find Y, what's the X first in order to find Y?
Huh?
Okay, so 500. So
Is it 504? So what we have right here is what's called a recursive sequence. We don't have an explicit. Remember, recursive, the only way to get to 500 is by going 1 to 2 to 3 to 4. I can't skip right to 500. It's not explicit. I need to convert this to an explicit formula. So the explicit formula, here's your next star. It's going to look like this. So last value is going to be equal to first. What was our first value that we got? So it'll be -3. And then I'm going to add, and I'm going to call it the common difference. So I'm going to abbreviate it with CD, CD. And if you want to know what that is, that's the common difference. Common difference times number of terms.
Number what?
Terms. 500 terms. And I forgot.
+1?
If we're doing it the reverse of that.
-1.
Yeah, -1. -1. I didn't even write the 1, Mr. Sindel. Come on. Get it together. There it is. Number of terms -1. Okay, now we have our explicit formula. So it's -3 plus, what was our common difference?
4.
There it is, 4. It tells us that right here in our recursive formula, where a sub I, I'm taking to find the ith value, I take the previous value and add 4. If I'm adding 4 over and over and over again, that is the common difference of 4. And then I'm going to take the number of terms. Number of terms was 500. And I'm going to subtract 1. All right, so to find this last term, to find this guy up here, I'm going to do 500 minus 1. That's 499. 499, I don't know why I had to type it in, times 4 is 1,996. And finally, what am I forgetting to do? That first thing?
-3.
-3. So 1,993 is my last value. 1993. 1993. That is going to be my last value. Do I have everything for my formula? What do I need for my formula? I need 3 things. I need the first thing. Do I have that? What else do I need? Common difference is used to find the last thing, so we don't quite need that, but we did need it in order to find the last thing. In order to just find all of the series added up, I need the first thing. Think about what Carl Friedrich Gauss did. He paired them up.
So it's
Rainbow.
So it's number of numbers.
Number of numbers, do I have that? I have that. It's 500. I have the first, I have the number of numbers, and to make the rainbow, I have to connect the first to the last. Do we have the last? We have all 3 components. Let's plug it into the formula. Don't think about the formula explicitly. Think about what he did. What was the general idea? Make the rainbow first. The rainbow added up what and what?
1993 and
-3 and add the -3. He added the first and the last. And they said, how many of those pairs of rainbows did I have? How many pairs do we have?
500. Divided by 2.
Divided by 2. There it is. Let's go ahead and do this on our calculator. So we're going to do 1990, because that's 1,993 minus 3. And then we're going to multiply that by 250. And we get 497,500. 497,500. 497. 497,500. Final answer, box it. Are we good? All right. That is all 3 possibilities that you will see on the homework and on the test and on the quiz. All right, go ahead and write your summaries now. Actually write it, Rochelle. I'm going to be watching you. And then once you finish that, you can do the Khan Academy homework. That concludes today's lesson.